Question 6, and we've got no numbers at all. This is an algebraic one. We're told that the particle is moving at a constant speed around a circle radius r. So the radius is r, the centripetal acceleration is a, so we know that as well. And we're trying to work out the time taken for 10 complete rotations. And I'm just going to write t with a little 10 as a subscript there, just to make the algebra a bit easier to write down. So we're going to need to come up with some sort of equation that involves r and a, either by using time period or frequency. And there's an equation actually that relates the angular speed, or the angular velocity, with the radius and the acceleration. We don't have a term for angular velocity here though, so we're going to need to change it a little bit. So we've got a is equal to omega squared r. And luckily for us, we know what the value of omega is. It's 2 pi f, so we can replace that omega squared with 2 pi f all squared r. So now we've got our equation in terms of a, r, and f. And it's quite easy to convert between f and time, because the frequency is just 1 over the time period, so that's not going to be too bad. The first thing we need to do is turn this so that f is going to be the subject for this particular equation, so we can rearrange this. First thing we want to do is take r down there, so we're going to have a over r is 2 pi f all squared. We can square root that, so we do those two steps side by side, a over r, and then square root that. That will give us 2 pi f. Okay, so now what we're going to try and do is put f as a subject, so that's going to leave us as f is 1 over 2 pi root a over r. F is 1 over 2 pi root a over r. And of course the time period is 1 over the frequency. So if we're going to come up with an equation for the time period, we can just flip the whole thing over. So the time period, and remember this is the time period for one oscillation, is it? Are we looking at SHM? Are we looking for circular motion? Circular motion. So the time taken for one rotation. In this case, just flip it. So instead of 1 over 2 pi, we just got 2 pi. Instead of root a over r, we've got root r over a. And then all you've got to do is work out how long it's going to take the 10 rotations. This is the time for one rotation, so literally just multiply it by 10. So we could write that t10 is going to equal to 10 times this, which is going to be 20, isn't it? 20 pi root r over a, which is going to be option D.